Imagine for a moment an ancient mariner. She carefully places a sealed bottle containing a message into the vast, churning sea. She has no idea who might find it, or when, or if it will ever be found at all. It's an act of pure hope, an expression of a fundamental human desire to reach out, to say, "We were here." In the latter half of the 20th century, we did something similar. We took two intricate, robotic explorers, crafted them with the best of our knowledge, and hurled them into the cosmic ocean. The Voyager mission wasn't born from a single mind, but from the collective genius of thousands of scientists and engineers at NASA's Jet Propulsion Laboratory, or JPL. Think of it as a modern-day cathedral, built not with stone and glass but with equations, circuit boards, and an unyielding passion for exploration. These were the people who dreamed of a grand tour of the outer solar system. They noticed a rare alignment of the planets, a cosmic billiard shot that happens only once every 176 years. This alignment would allow a single spacecraft to use the gravity of one planet to slingshot itself toward the next, a celestial chain reaction of discovery. The purpose was twofold, and both aims were breathtakingly ambitious. We wanted to study Jupiter's Great Red Spot, see Saturn's rings in detail, get our very first close-up look at Uranus and Neptune. Voyager was our robotic detective, sent to gather the evidence. But the second purpose was something more philosophical, more enduring, a message to the cosmos. To the untrained eye, the Voyager spacecraft might look like a strange collection of dishes, booms, boxes. But every single piece is a marvel of purpose-built engineering, designed for a long and lonely journey. The most prominent feature is the large 12-foot-wide high-gain antenna. This is Voyager's mouth and ears. It's pointed precisely back toward Earth, a tiny blue dot billions of miles away, to send its precious data and receive our commands. The faintest whisper from this dish is captured by giant radio telescopes back home. How do you power a mission that travels so far from the sun? The answer lies in a remarkable piece of technology called a radioisotope thermoelectric generator, or RTG. This device contains pellets of plutonium-238. As the plutonium naturally decays, it generates heat. The RTG converts this heat directly into a steady supply of electricity. Stretching out on another long boom like a robotic arm are the science instruments, Voyager's mind. Attached to the side of each Voyager spacecraft is a golden phonograph record. This isn't just a piece of hardware, it's a piece of our soul. It's our message in a bottle. Officially titled The Sounds of Earth, this 12-inch gold-plated copper disc is a time capsule, a greeting to any civilization that might find it adrift among the stars. The team, led by the great astronomer Carl Sagan, was faced with an incredible challenge. How do you summarize the entire human experience for an audience that knows nothing about us? The record's cover is a diagram, an instruction manual for an alien species. It includes a map showing the location of our sun relative to 14 known pulsars, cosmic lighthouses whose unique pulse rates could allow an advanced civilization to pinpoint the time and place of our origin. It also includes diagrams explaining how to play the record, showing the correct speed, how the stylus produces sound from the grooves. It even depicts the hydrogen atom as a fundamental unit of time and length. The contents of the record are a beautiful and poignant collage of life on Earth, our science, our art, ourselves. Following the images is a collection of sounds from our planet: wind and rain, the cry of a whale, the chirping of birds, the roar of a volcano. Finally, the record carries music, the language that Sagan believed could best transcend cultural and even biological barriers. And it carries spoken greetings in 55 different languages, ancient and modern, ending with a simple hello from the children of planet Earth. The cosmic journey began with a precisely timed departure from Cape Canaveral, Florida. Voyager 2 was the first to leave, launching on August 20, 1977. Its twin, Voyager 1, followed a different, faster trajectory, launching 16 days later on September 5, 1977. Although it launched second, Voyager 1's path was designed to overtake its sibling, setting the stage for a staggered arrival at Jupiter and Saturn. Voyager 1 was the first to reach Jupiter in 1979, with Voyager 2 arriving a few months later. The images they sent back were nothing short of revolutionary. Voyager discovered active volcanoes on Io spewing sulfur hundreds of miles into space, the first time active volcanism had been seen anywhere other than Earth, and it revealed that Europa was covered in a shell of ice, beneath which we now speculate a vast liquid water ocean might exist. Next stop, Saturn. Voyager 1 flew past the ringed planet in 1980, followed by Voyager 2 in 1981. They transformed our view of the rings from a simple, solid-looking band into a breathtakingly complex system of thousands of individual ringlets. In 1986, Voyager 2 made the first-ever visit to Uranus, finding a pale blue world tipped over on its side, with a bizarre, corkscrewed magnetic field and a host of dark, previously unknown moons. Then, in 1989 it reached Neptune, the final planetary port of call. It discovered the Great Dark Spot, a storm similar to Jupiter's, and captured stunning images of Neptune's largest moon, Triton, with nitrogen geysers erupting from its frozen surface. On August 25, 2012, a new chapter began. Voyager 1 officially crossed the heliopause, the boundary where the constant stream of charged particles from our sun is overcome by the interstellar medium. Voyager 2, on its different trajectory, followed suit, crossing into interstellar space on November 5, 2018. As of today, August 20, 2025, these intrepid explorers are still operational, though their power supplies are dwindling. Voyager 1 is now over 15.4 billion miles, or about 24.7 billion kilometers, from Earth. Voyager 2 is not far behind. One of the most iconic images of the entire mission was taken at the request of Carl Sagan in 1990. As Voyager 1 was leaving the planetary neighborhood, it turned its camera around one last time to take a family portrait of the solar system. From a distance of nearly 4 billion miles, Earth appeared as a single tiny point of light, less than a pixel in size, suspended in a scattered sunbeam. Sagan called it the pale blue dot. The Voyager mission is a story of epic proportions. It redefined our solar system, revealing a place far more dynamic, diverse, and beautiful than we ever imagined. These two small spacecraft carry our music, our greetings, our hope. They will wander the Milky Way for eons, long after we are gone. A testament to the fact that once, on a small blue world, a species of curious beings looked up at the stars and dared to reach for them.